Welcome to Transformations, and the first thing we're going to talk about for transformations is vertical and horizontal shifts. So we're going to talk about many functions, but a horizontal shift would be if I went from left to right, or right to left, doesn't matter. Basically, when you shift horizontally, you affect your x values. If you want to do vertical shifts, like shift your graph or your function up and down, this is going to affect your y values because you're moving up and down in that direction. Alright, I'm going to start out with a main function. It's y equals x squared. And I have f of x equals x squared, but let's write y equals x squared. So in this case, if I look at it, and I actually have the table right here so you can see, is I picked a regular old parabola right smack here at the center 0, 0, and a parabola, if you look at it, the center 0, 0, and see how the y's kind of repeat because it's symmetrical about the y-axis. It's a basic function. Now I want to move this graph. I want to shift it. So this looks like here, let's look at our picture, it looks like I shifted up 1, 2. So right now my center's here. It looks like the same graph, but it's been shifted up 2. So I went up 2. Now if I look at the actual function itself, you'll see that y equals x squared is right here. That's my original function. So here is y, because y is x squared. Let's write a y here. So y, and then I'm going to add 2 to it. That shows that if I add 2 on the outside, it shifted my graph up 2. Now if you'll notice I took my y's and I added 2. So when you want to show this, when you're graphing is, you're going to take your original points of your table, you're going to make an arrow because you're transforming it, and all I'm going to do is take all my y values and add 2. So our new table will look like this. Your x's will remain the same, so I have -3, -2, -1, 0, 1, 2. And your y's, I'm going to add 2 to all my y's. So when I do that, I have here, I have 11, and then 6, 3, 2, 3, 6, and the last one is 11. So when I ask you to show transformations, you're going to be doing a lot of this, where you show me the original table, show me an arrow that you shifted it, I added 2 to all my y's, therefore my graph moved up 2. Right? Now let's look at our original here, and then we're going to look at this graph. This one looks like it's been shifted down 1, 2, 3. So it looks like it's moved down 3. Let's look at our function. Here's my original function, f of x equals x squared. So there's my y, and I subtracted 3. So I took all my y's and I subtracted 3. So now my graph, my table, is I'm going to kind of do the arrow from here because you're doing it from your original functions. I'm going to take my y's and subtract 3 and leave my x's alone. So here's my x's and y's. I have -3, -2, -1, 0, 1, 2, 3. And now all my y's will be down 3. So I'll subtract that. Okay? So you're going to be doing a lot with tables to show how the graphs work. Okay? Now, let's look at what we see here. Now, the one thing is, let's kind of go back here quickly. When I did this one right here, I want you to notice a couple things. We call this an outside change for both of them because I added a 2 and subtracted 3's, okay? So when I added the 2, when I added it moved up, when I subtracted it moved down, okay? And it's outside the function of x squared. Alright, let's look at this one. I still have x squared, but now I'm doing what I call an inside change. Because look what's happening. I have my original graph here of y equals x squared again, same table, but notice I'm changing things on the inside in that spot here, okay? So instead of thinking x squared, I have something squared, a box squared, and I'm changing it on the inside. So we call these inside changes when you change your x's. Now, All right. The one thing I want you to notice is I'm going to do this. So I look over here and I see that this one looks like it's been moved over 1. Even though it doesn't show the whole thing, if that bothers you, just kind of add that to it. So it looks like it went over 1. So when I look up here, I'm thinking this should say x plus 1, but it doesn't. It's opposite. So the one thing you got to remember about inside changes, they're always opposite. You do the opposite thing with your points. So this looks like I'm subtracting 1 from my x's, but really I added 1 to them. So when I do my table, okay, inside changes are opposite, I am going to say I have to add 1 to my x's, even though it shows a minus. So I have x and y. My points are, my x's are going to change in this case, and my y's all stay the same. So I have 9, 4, 1, 0, 1, 4, 9. And my x's, I'm going to add 1 to them. So it's -2, -1, 0, 1, 2, 3, 4. I think I'm off 1. 0. They go like this. Sorry, guys. They're a little crooked. Okay. This one, I'm going to extend it. Looks like it's been shifted this way, and it looks like I went over 2 places to the left. Let's look. Look, it's positive. It's opposite what you think. So this is an inside change. This is actually an x plus 1 when I shifted it. This one was actually an x minus 2. So I'm going to go back to my original function, do my table, x's and y's. My y's stay the same because I didn't touch. I'm not going in the y direction at all. All I'm doing is now I'm going to subtract 2 from all my numbers. So I have -5, -4, -3, -2, -1, 0, 1. Okay? So the one thing I want you to notice about this is outside functions kind of go the way you think. Positive is up, negative is down. If I switch up and down. When I switch it on the inside, or my x values, when I'm shifting it left and right, it's the opposite of what you think it should be. All right? So let's summarize. What are the rules of vertical and horizontal shifts? Well, vertical shifts, when we add or subtract a constant from the function, we call this a vertical shift or outside shift. Okay? Vertical shift or outside shift. The effect this has on the table, it keeps the x values the same and shifts the y values by k units. So how would I write that is, if I shift it up, it's a positive k. If I shift it down from my constant, it's a negative k. So, and it's outside this. Horizontal shifts, this is the one that is opposite. When we add or subtract a constant within the domain or inside, this is called a horizontal shift or an inside shift. The effect this has on the table is it shifts the x values left when k is positive, okay, and shifts the x values right when k is negative. So in this case, if I go to the left, it's a positive k. If I go to the right, it's a negative k. So it's opposite of what you think. All right? So there's a good summarization. You need to know these rules, so it's good to have it on one slide. All right, the next thing we're going to talk about is reflections and symmetry, and we're going to reflect over the x-axis, reflect over the y-axis, and we're going to talk about even and odd symmetry. So let's kind of draw a little picture first, okay? And remember a little rule we did in geometry. So here I have this really nice little triangle here. See if we can draw this nice. This is my x-axis and this is my y-axis. Now, if I want to reflect over the x, now let's see if I can draw this. I would fold it on the x and it would kind of look like this. All right? If I wanted to reflect it, sorry guys, I keep hitting stuff, I apologize. If I want to reflect over the y, you're going to fold it on the y-axis and it would kind of look like this. Sorry, my drawing's not perfect, but hopefully you get the idea. So here's my point xy. If I reflect it over the x, my x's stay the same, but my y's will be all opposite. If I reflect it over the y's, my x's will be opposite, my y's will stay the same. So what I usually like to say this to the kids is, if you reflect it in the y, which means the y-axis, you change your x's. is if you reflect it in the x-axis, you change your y's. So I usually kind of get going a little sing-songy voice. When you reflect it in the y, you change the x. Reflect it in the x, you change the y. Reflect it in the y, you change your x's. Reflect in the x's, you change your y's. So it makes sense when you see it, but it's a quick way to look at how it's going to be. Okay? Let's look at some reflections then, all right? So I picked an exponential function this time. I picked y equals 2 to the x. And I am going to stick a negative in front. Well, remember, y equals 2 to the x. 2 to the x equals y. So I can basically say, well, this means negative y, because if y equals that, it's negative y's. Well, if I change my y's, didn't I reflect it in the x? And if you look at it, doesn't this look like, right here, this has been reflected over this axis over here, that it's been reflected. So all you do to reflect in the x is change all your y. So if my x's all stay the same, like I have there, when I reflect it in the x-axis, I have to negate all my y's, and then they all just change signs. Okay? Which makes sense, all right? Over here, notice, oh, by the way, this is an outside change. Okay, this again is outside. This one, I negated my x's. So if I negate my x, I reflect it in the y. And that's what that little sing-songy voice I did. So here, I'm going to take my original function here, and I'm going to negate all my x's, or change all my x values with an opposite sign. So my y's will stay the same. My x's will all be opposite, except for 0, of course. Okay, so reflect it in the x, you change the y. So this is an inside change. Okay, so if I negate the outside, I reflect it in the x. Negate the inside, or my x's, I reflect it in the y. So here's our rules of reflections. The graph of y equals negative f of x is a reflection over the x-axis, and because it's negative y's. And inside, it's negative x's, so it reflects it over the y-axis. Okay? This is an outside change again. This is an inside change. All right. Now, I want to do one with you that has multiple transformations in it. So I picked this little weird function here, and I don't know why, but not all the grids show up. So I'm going to pick some of the points here that I have. I want it to go through here, and it's here and here. So I'm going to kind of write it nicer. It's hard to put this on there when I was actually putting it on there. It doesn't really come out right. So I have this little weird looking function here. All right. So this function is called p of x. And if I were going to list the points, so my original function is going to be, I'm going to use the point negative 5, 0, because that's what I meant it to be. Negative 2, 3, 0, 0, 2, negative 2, and 5, negative 2. Now, I want us to do this to it. Come up with this new function, v of x, where I have to do a shift on the inside and outside. Now, see how this says work inside out? That's how I want you to do. You're going to work and do this first. Work on the inside, and then you're going to move out. So my function p of x is here. Do you see how I've added a 2? So that's an inside change. So I'm going to list my points here, because this is what you're going to do. So here's p of x, where I had my points that I just showed you before. Negative 5, 0, negative 2, 3, 0, 0, 2, negative 2, and 5, negative 2. Now, the first thing you're going to do is we're going to do this to it. So if it's an inside change, it's opposite. So I'm going to subtract 2 from my x's. So really what I'm doing to this graph, I think, it looks like here I'm going to shift it to the left 2. That's the first thing it wants me to do. The second thing it wants me to do is to drop it after I shift it down 5. So this graph should look the same, but been shifted over and down when I'm done. So we're not going to graph the in-between step, but we will graph it at the end. So if I want to shift it to the left, because that's what x plus 2 means, I'm going to subtract 2 from all my x's, and my y's will stay the same. So my y's are 0, 3, 0, negative 2, negative 2. My x's will be then subtract 2 from everything. Now I have shifted it to the left. Don't graph it, okay? The next thing I want to do is drop it down. Now this is an outside change, so that's my y's. I'm going to subtract y5 from all my y's, but you don't have to go back to the original. You use this table of points right here. So my x's are going to stay the same. I got negative 7, negative 4, negative 2, 0, 3. My y's are going to all drop down 5. So I'm going to subtract 5 from every single thing there. Okay? Now, when I graph this, it should look like I went to the left and dropped it. So let's try. So I get negative 7, negative 5. Then I get negative 4, negative 2, negative 2, negative 5, 0, negative 7, 3, negative 7. So when I connect them all, doesn't it look like that I took this, shoved it over here too, and dropped it down? That's where it should be. So you just did both transformations all at once. Okay? So this is a horizontal shift to the left, and this was a vertical shift down. Okay? All right, I want to talk a little bit about y-axis symmetry or even functions. An even function here is, it looks symmetrical about the y-axis. So if you look at it, and that's what the parabola was an even function. It was y-axis symmetry. Is if I had an xy and a negative xy, it makes it look like you could fold it right over the y-axis, okay? That means it's symmetrical. So this is important. F of negative x equals the same as f of x. So if you want to test something to see if it's symmetric about the y-axis, you test with negative x. So let me show you. I'm going to give you an example. So if I had f of x equals 3x to the 4th minus 2x squared, okay? And I wanted to see if that was symmetric about the y-axis. I test with my negative x, put a negative x in, and if I get the same thing back, then it's symmetrical about the y-axis. So I'm going to put a negative x inside each of those spots. And when I do that, I get the same thing back, because when I take negative x raised to the 4th, it's the same thing. The negatives all cancel out. I end up coming back with that. And if I have negative x squared, it's the same thing. So I end up coming back. These two are the same thing now. If I get it back, all right, then I know it's symmetrical. So if you test with negative x and you get the same equation, then it has y-axis symmetry. It's symmetric. It's an even function. Okay? The last one is origin symmetry or odd functions. So if I have a point here, now odd functions, they are a little bit different, but they do have this own kind of symmetry. They are symmetrical about the center of this. And if you look at it, if I had the point xy and a negative xy, it does have its own type of symmetry. So if you have f of negative x, it's the same as negative f of x. Now, here's the test. You test with negative x. This test, though, is if I put negative x in, if the whole thing is opposite, then it's odd, okay? So if I had f of x equals 3x cubed minus 2x, if I test that with a negative x, so I put a negative x right in that spot, if what I get back is totally opposite, then it's odd symmetry. It's an odd function. So it's negative 3x plus 2x. Do you see how this function and that function, all their signs are opposite? So that means it's odd function and it's symmetric about the origin. All right? So with odd functions, you test with negative x, and if all signs are opposite, I mean all of them, then it has origin symmetry or it's an odd function. But there's one thing. If I get mixed, sorry guys, if I get a mixed bag of odds and evens, if it's not exactly the same, like even symmetry, or if it's not all opposite, then it can be neither. Not all functions have to be either odd or even. So if you test it with negative x and it's not all the same or not all opposite, then it's neither. Okay? A function may be neither even or odd. Okay? Well, there's the first initial part of transformations. So I will see you in class. Thank you.